So we do the homework of 14C2 kinematics using the real derivative without using the first principle, using limit and so on. We try to go through the shortcut. Okay, as you can remember, if I have the position, I can use derivative to find the velocity, and I can use the second derivative to get the functions of acceleration. So it can be written as ds over dt. It can be written as d square s over dt, or dt square, or dv over dt. It's the same, yeah, because the first derivative of v, or the second derivative of s. So this is the first derivative, this is the second derivative of s, right? So this is the idea, but the question is quite challenging. Why? Because it needs the works. Remember the formula? The formula starts from the basic formula until the chain rule, until the logarithmic function, or the natural number function. Okay, and multiplication rule, division rule, and so on and so on. Okay, I think I need to copy this. There you go. So this is the basic concept, the blue part, and let me show you how to do. You can ask me whenever you think that you have any problem. Okay, now we have the functions of position, displacement function or position function, up to you. So you can find VT, right? The derivative of S, 100 plus 200. Remember this, E is a natural number that if you derive, it will get to itself, back to itself. So you don't have to change anything, but remember the chain rule, right? Times the inside. No, this is not 1 over 2, 1 over t over 5, Wait, give me a moment. I think I need to use pen. Negative t over 5, right? And then you multiply by the inside. The inside will be negative t or negative 1 over 5t. I think that's better for you to understand how to derive this. Negative 1 over 5 itself, right? So times negative 1 over 5 itself. So make it simple. Vt equals, that's for question A, yeah? 100 minus 440, right? Because this is 5 and 240, and put the negative in front, minus 40 e power negative t over 5. That's it. Okay. And how do you calculate the acceleration function? Okay, so velocity function is done here, right? Please keep in your mind about the e, right? The formula of the derivative of e. Now we go to the green part, acceleration. So acceleration is the double derivative of s, or the first derivative of vt. So at. Sorry, I need to put here the bracket. The bracket is extremely important. 100 is equals to 0, right? And minus 40 times, again, this will be unchanged at any cost because it is e power t power e power negative t over 5 times by the inside also. It is recurring. It's the same, right? So what is difference is only about the constant, right? First we have 200 becomes 40. Now 40 becomes something, becomes 8, right? So at equals to negative 40 times 5. You can cross it out. Becomes 8, right? And then negative 8 times negative 1 is 8 e power negative t over 5. That will be your answer on question 5a, right? So question 5a requires you the, what they call, the basic knowledge of the derivatives. Now B, find the initial. Initial is when the t equals to 0, right? Initial, when the first position. So initial. So B, we have 3 parts, st, s0, and v0 and a0. So you can just substitute the t by 0, but we don't want to waste time. Let's do with a calculator. Oh, no. Oh, okay, because we use E. So if we use E, if we deal with E, better use calculator in order to eliminate the possibilities of mistake. So S first here, 100 times T plus 200 E to the power of, wait, there you go, negative fraction 0 over 5. I think it's 200. Yeah, there you go. Okay, just substitute the T as 0. So it is 200. How about the V? I think we can just look at this. 100, right? Only 100. Let's prove if you don't believe it. Why? Because T is 0, 0 over 5 is 0, e power 0 is 1, right? Oh, 60. Yes, 100 minus 40 times 1, right? So 100 minus 40 times e power 0, right? E power 0 is 0 over 5. Any 0 over any number is 0 also. So e power 0, 1. So 100 subtract 40 equals to 60. If you don't get used to this, you might use calculator. So 100 minus 40 times e to the power of, if you are quite inconfident, no problem, 0 over 5, right? You just put it directly. See, 60. And how about when t equals to 0? Sorry, I lost my word. So 8 times 1, right? 8 times e power 0, 8 times 1, so 8 itself. If you don't believe, okay, you can use calculator. So that's 4 questions. B, we have 3 answers. B1, B2, B3. Okay. Now number 4, sketch the graph of the velocity function. Velocity functions, you cannot use, I think we can use the sketch or the graph sketch when v, this is v, velocity function, so v and t, as always, t always on the horizontal axis, t cannot be on the vertical, it will never be like that, just agreement. And look at the v, when v equals 0, sorry, when t equals 0, the v is 60, so 10, 20, 30, oh, it's not enough. Okay, so I think like this is better, 20, 40, and 60. Okay, this is the initial velocity. Okay, when I want to increase, so it is negative, right? So when it is negative and negative, I think this will going down, but we never know about this. Okay, so when t equals infinity, what happened to it? Okay, let's see that. So if t equals 1, if t equals 2, if t equals 3, and so on, what is the value of v? It will be so much. So what you need to do in order to solve this, you need to put the t as the infinity. Okay, try to make sense of it. So v infinity equals to, let's say, v 1000 or 1 million in 1 million seconds. Just think of the highest number. So equals to 100 minus 40 times e power negative blah blah blah, right, over 5. So this will be a fraction, right? Remember, if I have 5 power negative 1, it is equals to 1 over 5, right? 5 equals negative 1000 equals 1 over 5 power 1000. This is near to 0. Get it, Tedra? That's the way I think of the astronomical number about the t. Get the idea?
Yeah.
Okay, so when t equals near to infinity, so this answer will be near to 0, but cannot be 0. That's the rule. So 100 minus 0, right? Yeah, so 40 times 0. So 100 minus 0. So it's near to 100. So it is increasing. Okay, so the drawing is not so good like right now because we don't have the space of 100. So let it, I will make it one more time to make it more easily to see. 20, 40, 60, 80, and 100. And it cannot be more than 100, right? If I increase, so the velocity is increasing at the time, right? Because we start from 60, from t equals 0 as given, until 100. So draw a thin line, okay? And then the drawing supposed to be, I guess, like this. Okay, and going right and so on, getting nearer, but never reach 0. So let it be like this. Okay, so let's prove. Okay, again, I also inconfident about my answer. So let's try using this tool, GeoGebra. Okay, a moment. So the VT 100 minus 4t e blah 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 t negative t over 5. Hello, so long. Okay, y equals 100 minus 40 e to the power of negative x over 5. Okay, that's it. Wait, what I'm doing? Oh, there you go. It will be negative. The negative, just ignore the negative. Why? Because it doesn't make sense. Right, there you go. See, from 60 to near to 100, but never reach 100, by the way. If you zoom in and in, never reach 100. See, it is getting nearer to 100. If you go right and then you zoom in, never reach 100. If you go right and you zoom in, never reach 100 at any cost. Okay, because this is an astronomical number. What I said, astronomical number is the number that needs to be guessed. Okay, D. Find the velocity of p when wait, find when the velocity of p is 80. Oh, 80 cm over second. Okay, so when 80 cm over second, so the d, so v equals 80, and you need to find the t, right? When is asking you for the time. So just insert. Okay, we use pure algebra. 80 equals 100, subtract 40 times e power negative t over 5. Put it to the left, 40 times e power negative t over 5 equals to 20, right? I think I need to erase this. And then what next? E power negative t over 5 equals 1 over 2. Okay, and then what you do now in order to solve e, you need to put ln both sides. Okay, because ln e equals to 1. So the negative t over 5 is supposed to be bring down, go to the left, times ln e. Remember the logarithmic rule, Pedra? Do you remember this? Let's say log power b equals, you put the b to the left side, log a, right? And if I have ln e equals to 1, so ln e power n equals to n times ln e equals to n itself. So as you can see the proof, if I put ln e to the power of anything, for example 6, the answer is always 6. What's the error? Oh, the bracket, sorry. See, e power 999, it will be 999 also, but this is error. 9, 9, right? So if I have t negative t power 5, t over 5, you put the t over 5 to the left and can ignore the ln. Okay, because ln e equals 5, equals 1. Ln 1 over 2 needs to be done with calculator. We don't have any other formula. 1 over 2, close, bang. Negative 0.7, let's say. Negative 0.7. I do the rounding. So t equals, you put the negative out of both sides, 0.7 times 5, right? So the t will equals to about negative 3.5 seconds. Okay, it is in cm, yeah, cm over second. Okay, so no problem with the units. So that's for question A, B, C, A, B, C, D. Yeah, done. Ooh, so long. Okay, wait, give me a moment. I will send you the files later on. I will put it on Microsoft Word. So let's do the next question. Okay, the next question is number 6. Oh, oh my goodness, we use a trigonometric function and it will be the same on and on. Okay, believe me. What is the difference is only about the how you derive the functions. Okay, I don't want to erase this because it's still on the kinematic parts. Kinematic parts is talking about this displacement, velocity, and area. Acceleration, not area. Particle P moves along the x-axis. Okay, x equals 1 minus 2 cos t. So x t equals 1 minus 2 cos t. And then where t is time in second and x is cm. Okay, it's given. And state the initial position, velocity, and acceleration. Before you state the initial position, you need to state the function of the velocity and also the function of acceleration. Okay, 1, 0, right? Minus 2, cos becomes negative sine. Remember this? Negative sine t. So you can simplify vt equals negative 2 sine t. I did something wrong. Do you know what is the differentiation of cos? Negative sine. So it has to be plus. Okay, remember this rule. Sine becomes cos, cos becomes negative sine, tangent become, do you remember, Tedra?
Secant
There you
square
go.
or something.
That's nice. Secant square. So sine theta, cos theta, sine x, cos x, and so on. It can be anything. So I just ignore the units. Nice. So this will be our memorization of the derivatives. Okay. So sorry, something I did something wrong, but I already corrected right now. So we don't have to put the sign and use the a. So at, put the bracket. 2 times sine becomes cos t. Done. Okay, so I can erase this because this is only the way. So oh, no need to erase. I think we need to put the square on the important part. Bang. So question A, let's answer question A. Oh, initial position x0, v0, a0, 1 minus 2 cos 0, 1 minus 2 cos 0. Cos 0 is 1, right? Remember? So 1 minus 2 times 1 equals to negative 1 because 1 minus 2. That's for the initial position, cm. Okay, on the left, right? And v equals v when v of t equals 0 to 2 times sine 0. Sine 0 is 0, so 2 times 0, so it is at rest, cm over second. Start at no speed at all. And then 2 times cos 0, right? So 2 times 1, because cos 0 is 1, so 2 cm over second squared. Put the right unit. So don't get confused by, okay, I think I need to put meter over second. No, the unit is clear enough. Okay, that's for question A. Describe the motion when t equals pi over 4. You need the help of freaking table here. I think I forgot the circle thing. Remember, over 4. So, oh man, wait. Do you still remember that? I think I lost my memory in this part because I never used this kind of rules. Okay, let's try. Pi over 4 is 45. There you go. So this is square root 2 comma square root 2, right? Remember these rules? And then this is the multiple of pi over 4, yeah?
Yes.
Nice. So this is negative square root 2. Wait, wrong. It's not square root 2, half. We have the half. Wait. Wait. The radius is 1, right? The radius is 1. So this is 1 also. This is something, right? Oh, okay. Square root 2 over 2. Ah, there you go. Square root 2 over 2. And this will be negative square root 2 over 2, comma square root 2 over 2 because the x is on the left side, remember? and this also negative square root 2 over 2. The y is also negative square root 2 over 2 because it's below. There you go, and negative square root 2 over, no, square root 2 over 2 comma negative square root 2 over 2. The y is below, x is on the right side. And this will be pi over 4. This is 0, pi over 4, pi over 2, because 2 pi over 4, right? 3 pi over 4, 4 pi over 4, or pi itself, or 180, right? This is 5 pi over 4. This is 6 pi over 4, or 270, and this will be 7 pi over 4. When t equals pi over 4, you need to use this. This is cos, this is sine, remember? Cos, sine. Yep, there you go, cos and sine. Cos is for CS. So for question B, describe the motion when t equals pi over 4. So B, x pi over 4. Just write it down, right? And then V, pi over 4, write it down. So you don't have to be confused about the value of sine cos because we already did this table. Okay, and A pi over 4. Okay, just insert 1 minus 2 times cos pi over 4. Square root 2 over 2. Right? And then we don't have to solve this later. So 2 times sine. Wait, I think I need to put this. There you go. Slowly, yeah. 2 times sine pi over 4. Okay, I think my handwriting getting worse. Cos pi over 4. I don't expect that one question can waste about 15 minutes. Now, cos pi over 4 is square root 2 over 2. So 1 minus 2 times square root 2 over 2. 2 times square root 2 over 2 also. So it's the same, yeah. No problem. Square root 2 over 2. This is 1 minus 2 square root 2. Square root 2. And then square root 2 also. Cm over second square. Cm over second. This is cm. So this is on the left. Get it? Because if you want to do the calculation, 1 minus 2 square root 2 is negative 1.8. Okay. So you can determine that the particle is on the negative on 1.8 cm to the left, on the left, I mean, and moving with a speed 20 cm over second to the right because it's positive, and its acceleration is square root 2 cm over second square, increasing its speed because it's still positive. If it is negative, decreasing. So this is accelerating. Okay, this is the idea, the answer, this one. Okay, you need to predict, or not predict, you need to determine describing the position. Okay, let's go next, part C. Find the times when the particle reverses its direction. So reverses direction. So you need to find the ds over dt. Reversing direction means, oh, yeah, ds over dt equals to 0 from become left and going right. Wait, I think I did something wrong. No. Reversing direction. Reversing direction is when I think I need to memorize this. Reversing direction. Is when, wait, give me a moment. To reverse the direction is when v equals to 0, as it is given on the question reverse on the table. When it is v equals to 0. Okay, memorize. You need to memorize this because I never memorized this kind of understanding. 2 times sine t. The times, so it has to be plural, but in 0 until 2 pi. Okay, so sine t equals to 0 over 2. So sine t equals to 0. So t can be the sine of something equals to 0. Okay, so it has to be here. Sine here, right? because this is 2 pi over 4, so this is 1 comma 0 comma 1, right? 1 comma 0, okay, the right side, the sign, and this will be negative 1 comma 0, right? This is 0 comma negative 1, and when the sign is equals to 0, the theta will be either 0, so t could be 0, or t could be pi, right here. You are finding the angle pi or 2 pi itself, right? Back to original, right? 2 pi itself, but it is not asking you for 2 pi. And also, wait, I give you all the possibilities. Okay. Find the times. It is plural. No, it's singular, because when t equals to 0, sine t equals 0 is only one possibilities, because it is eliminated, right? Eliminate this and eliminate this. So you need to find the position. So at t equals pi, as given, because this is reverses direction, this is the rules of reverse. So the x pi equals to x theta, I mean, no, x pi, yeah, that's right, it's pi. 1 minus 2 times cos pi, right? So 1 minus 2 times cos pi, where is the pi? Here, cos negative 1, okay, negative 1. So at negative 1 meter, so it changed its direction, okay? Now, when is the particle's speed increasing? When is the particle speed increasing? At t less than 0, 0 less than t also. Okay, when if the particle speed is increasing. So when the a is positive, right? So the more the speed or the velocity is increasing when the a is positive, right? So you need to use this 2 times cos t more than equals to 0. That need calculator. I mean the graphing calculator. 2 times cos t more than 0. So you need the help of calculator. 2 cos t. So y equals 2 cos x. Increasing is where the a is more than 0. I will change the settings. The x will has to be theta. Pi. I mean pi. There you go. No, half pi. Yeah. Okay. That is your answer. So, okay, we got it. I got it. No. So this is for A, yeah, for part A, because y 2 cos. So this one 2 cos t. So the curve will be like this, and when 2 cos t more than 0, it has to be here, right? This is positive part, and this. Okay, so the time interval will be 0 t half pi, right? Or pi over 2, and or yeah, or pi over, this is pi over 2 pi, and then this is 3 pi over 2, or 3 pi over 2 t, and then 2 pi. I think this will be the answer. Okay, get it, Tedra?
Yes.
Okay, this hard. So I have to admit that this question requires a lot of working. I think it's so few questions. I think we can finish it in 30 minutes, but dream on. Number 6, 7. Okay. You need the help of the graph right now. In an experiment, an object is fired vertically from Earth's surface from the position dimensional t above the surface plotted, and then st in meter. Okay, and then it is noted that the graph is parabolic, so it is a quadratic equation. Okay, so it is quadratic function. I mean, so we have the you need to pick one point as a vertex, right? And this is the vertex, and this is where the particles try to turn back or back to Earth surface, and s equals to, so if it is quadratic function, so st equals a t square plus b times t plus c, right? It can be a x squared plus bx plus c. Remember this? Ax squared plus bx plus c as the quadratic function. Okay, and we have the gravitational acceleration, so we need to use the help of vt. Vt is 2a times t plus b. Okay, next, what is b? B is the initial velocity. Okay, but I think we need to get to the idea first, and then at equals, oh man, what I'm doing, 2a only. Give me a moment. Yeah, oh my goodness, this is so hard, this is so conceptual. Wait,